Question number 20 says the graph shows the speed in meters per second of a particle over the first 4 seconds of motion. And we can see we've got another one of these speed time graphs like we had earlier in the same paper. But this time we're calculating or estimating the distance travelled by the particle in the 4 seconds that the graph shows. Before, we had a question that asked us to calculate or estimate the acceleration. And we did that by finding the gradient of the tangent of the curve. Different this time because we're working out the distance, and to work out a distance or estimate the distance, you have to work out the area underneath the curve. Okay, now we've got a range of different answers we can give our answer as, because everybody's going to calculate it slightly differently. Basically, there's a few different ways you could do it. You could split it into triangles and rectangles or trapeziums if you want to be really, really specific about it. Work out the scale. You know, you could take a lot of time on this question and get a really nice, accurate answer. But we don't need to because we've only got 2 marks. So really, we don't want to spend too much time on it. If you've got loads of time left at the end of the paper, by all means, spend ages working out what the area is using your trapeziums. But for me, I think the easiest way to do this question would be to split it into unit squares. So you've got this distance between 3 and 4 seconds is 1. This distance between 0 and 1 meters per second is 1. So you're going to have a 1 times 1 square. If you split it into these squares, you can then see them as being 1 squared unit. So see how many that is, and count them up, and that's how many meters it is. That's how it works. So I'm going to split these up by popping some lines on this graph. So splitting it up into the units and then just roughly counting the squares and seeing how many we've got. It's maybe not the nicest way to do this question, but it is a way and it will work. So there we go, split that up and we can see how many whole squares we've got there. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now we've called a few of these whole squares, so let's just discount this top bit here. 13, 14, 15, 16, let's say 16 or 17. You can count them a couple of times, all right, and see what you get. All right, we're just saying that this bit here and this bit here would make this bit here a whole square, so we can count all of this area. If I just shade that in, we can count that as 1 square, 2 squares, 3 squares, 4, 5, 6, 7. I'm going to call that 8, 9, 10, 11, 12, 13, and then 14 would be that one and that one, 15 and that one and that one, and then this one could be 16. Let's say 16 meters as our final answer, as our rough estimate as to the distance travelled by the particle in 4 seconds. Work out the area under the curve.